The broadcast is now starting. All attendees are in listen-only mode.
Okay, good afternoon, everybody. Sorry for being late. I came running like crazy from home. So, this is the second session, and we do have construction. This morning I was here talking to the transportation group, and right now it is your turn. And let me bring the camera and let me bring. Okay. Let me get the camera here ready for you guys. Okay, so today is Saturday, the 27th of June, and this is a construction workshop, and I hope that all of you are healthy and all of you are studying very hard for the exam, for the October exam. Always check with the NCEES, as I mentioned before many times. So today we have a session, and tomorrow also have a session, by the way, for construction. We have it from 9 to 12 tomorrow. Not as posted from 1 to 4, because I found there is a conflict between go home, and as I announced it this morning, probably some of you were here this morning, so already you heard this before. So yes, so for the civil AM, as I mentioned, that that I will have one session. July 4th is coming, July 4th from 1 to 4. Transportation, I finished today, so no more sessions. I made one session to replace one of these sessions I missed here. So, construction, I have 27 today from 1 to 4, and tomorrow 6/28, the 28, instead of 1 to 4 is from 9 to 12. So from 9 to 12, because I do have seismic tomorrow from 1 to 4. So there was a conflict. So I changed it, and I believe it was sent to you. The same ID, there is no change. And even the additional session that it will be held on July the 4th for the Civil Breadth AM is also based on the same ID. So the same ID, there is nothing really you need to do other than just join me if you decided to join me, and you will still have time to go to do the fireworks or do the kids fireworks if you like to they are going to celebrate this year with the standard, or this is the regular fireworks for the 4th of July. So you still have time. You still have time after 4 o'clock. You can go and enjoy the family and enjoy the celebration with the family. So construction, and as I said that too many problems, and I covered many problems. I would like to jump today to talk about something. Okay. I covered it before, but I received a couple emails about materials. Please make sure that you really understand the materials very well, especially the soil classification, because and in this book here, for some reason, that's why when I start the class, I will send it to you guys, because if you look to the NCEES, the NCEES, let me bring the one of the books, the NCEES books here, if I have it handy. They still include some problems related to the soil classification for the afternoon for transport, for construction. Sorry, here it is. So, for example, this problem here, which is from the NCEES, So the NCEES practice exam for construction in the afternoon. This is a construction PM, a practice exam. I don't have a formal chapter for it as far as the soil classification, and I need to include this or send it to you. I cover it for the AM. Yeah, I do cover it for the AM. Yes, I do cover it for AM, but I will be glad to include it also with the PM for construction for those of you who are not taking the PM. So the soil classification, some problems are easy and some problems are really tough. Okay, let's start with an easy one. So the soil classification, problem 525, laboratory testing was performed on soil sample with the following results. And they said that SIF number 3 inch, 1.5, 3/4, and number 4. Here, anything before number 4, by the way, they express it in terms of inches, okay? And after that, they start to number them 4 all the way to 200. So this is 4 openings per linear inch, 10, and so on. And they provide the liquid limit and liquid limit and the plastic limit, PL. And as you know, there are 2 systems. Here he needs it, okay, to be classified based on Unified Soil Classification System, USCS, Unified Soil Classification System. We will do it, but before I will go to USCS system, I will challenge you. And they said, okay, let us solve the same problem. First of all, before I put the problem, I will call it a problem 525A, okay? Another problem. I need the soil classification based per AASHTO, for the same given information. And I will look for 4 answers, and here will be the challenge. And see if we're going to come up with 4 answers different, or all of us are going to come up with 1 correct answer. But before I give you 2 or 3 minutes to do it, be careful about this. This is percent passing. Sometimes they give you percentage retained. So there is a huge difference. And a common mistake that I found it in the past, that today is 6/27, and this is construction. So when you have a SIF, okay, like number 4, okay, number 4, which we said that 4 openings per linear inch, 4 openings per linear inch. This is why you will find that the opening of each one, I know 1 inch, as you know, is 25.4 millimeter, 25.4 millimeter, sorry, 25.4, sorry, millimeter, divided by 4. So if you divide 25.4, this will give you about 25.4 divided by 4, it is 6.35. 6.35 millimeter per opening. But you will find that the actual opening for number 4 is not 6.35. Okay, you'll find that number 4 and number 200 are extremely important, and they are given everywhere in my books. But unfortunately, in the construction, as I told you, that for some reason that they are not there. But in the Civil Breadth AM, my Civil Breadth AM book, and I will send this section to all of you under materials, you will find that number 4, it does have only 4.76 millimeter. So it's not 6, so it is 4.76 millimeter. This is for number 4, the opening. And number 200, which is also very important, it is 0.075 mm. So these two numbers are there. Okay, so be careful on the problem statement. Read, it is percent passing or percent retained. So if this is number 4 and he giving me, okay, for example, this is percent for number 4, percent passing 77. That means that the percent went through, it is 77%. What is retained? Retained is the difference between 100 and 77. 100%. So that means that what is retained here is the 23% retained. So this is retained and this is passed. Okay, the percent passing or the percent passed. Sometimes they give you this and sometimes they give you this. In our case, he gave us this. He gave us the 77%, the percent passing. And the same story for, so this is the one that went through is 77%. That means that I have 23 retained. And if you go to number 200, I have 18% passed. That means that I have 82 retained. So we need always to remember this, the difference between retained and passed or percent passing. Okay, liquid limit, plastic limit, and he will give you the soil classification. Here it is, you are lucky, or we are lucky, it is a single symbol. Sometimes they give you the problem with the dual symbols. So if the dual, so in this case, we have to find the, so the chart that we use for the unified soil classification system, very famous chart. It's available everywhere in my books, and I'm sure that you have it. Okay. This, for example, from the AM book. But I will move to the AASHTO first. If you don't have the chart, here is a chart. Here is a chart for the AASHTO. So this is the chart that we use it for the AASHTO soil classification system. Okay, I hope it's clear. If it's not clear, here it is. I will make it clear. And as you recall, or as we discovered, or as we found, or as we discussed, this chart is divided into two main sections. This section here, which is the green box, okay, this is the granular materials less than or equal 35% passing number 200. And the blue one, which is the one next to it, which is this here, where we have more than 35% passing. Here is less than or equal 35%, and here is greater than 35% passing number 200. So if we are able to, and after that we have number 10, number 40, number 200, and here, by the way, the 0.075 millimeter. And here is what else here? Number 40 and number 10, they have number 4, they don't have it here, which is a 4.76. So in this case, we need to decide if we are in the green box or the blue box based on the percentage that passing number 200. And the problem statement, it told us, here it is, already I did it for you. So this is number 200. So we have 18% passed and 82% retained. Okay, so, and after that, using liquid limit and the plastic limit, let me give you a chance for all of you using this problem and using the table in front of you, and let us come up with the AASHTO system is based on the, we call it the A system, as we call it. So it is A1, it could be A1A or A1B, A3, A2, and we have subgroup under A2, and after that A4, A5, A6, and the A7 is divided to A7, 5, and A7, 6. Okay, so there is another column here. It is A-8, by the way, but it's dropped. A-8 is the worst soil exists on Earth. Okay, is not good at all for any kind of foundation, and this is why some books drop this column completely, because it is very bad soil, very bad soil. And as you can see here at the bottom of this table, you'll find that we do have excellent to good. So A1 being the best, by the way, and the soil is deteriorating as we go this way. This is fair to poor. So the soil quality is deteriorating. Soil A1 being the best soil, and A8 is the worst. We cannot really use it at all for any kind of foundation, either for a pavement or for a house or for any kind of foundation, because it is organic material, soil that has a lot of organic materials. And as you know, the organic materials, we cannot compact it, because if you remember the compaction, 90%, 95%, and so on. We talked about this before. Let me give you a few minutes, and I'm looking for the problem 525. I need you to classify per AASHTO, which is the A system. Give me the A number, and we will see if we are agreeing on one answer or what's next. Let me give you a couple minutes and do your best. And let me just zoom a little bit out just in case. Okay, so problem 525 of the NCEES construction PM. What is the soil classification bear? I get A24 A-2-4 and A2-4 and 0. Okay, and I will talk about what is meant by this here, this 0 here. Okay, so we got two answers so far. Another answer A24. Okay, so look into this chart here. We have the 18% passed, number 200. So I am in the green zone, less than 35% passing, number 200. So I am in the green. So I will see number 10. Okay. Number 10. I don't have any information about number 10 for whatever reason. And number 40, I have number 40. Also, it's blank. So I will skip these two. So number 200, I know percent passing is 18%. So number 200 here is less than or equal 15, less than 30. So this is out and this is out. So A1 and A3 are out. So 35, all of them are eligible. So A24, A25, A26, and A27. So I am in this category here, A2. Okay. And safe number characteristic of the fraction passing. Okay. So I have the liquid limit and PI. PI plasticity index, as all of you know. So plasticity index PI is liquid limit minus plastic limit. Liquid limit is 32 and the plastic limit is 25. So this 32, so this is 7. So PI, the plasticity index is 7. So in this case, I am 7. So here I will come liquid limit. I have 32. So this is less than 40. So this is or equal 40. Greater than, this is out. Okay, less than, it may be. Greater than, so this is out. It's a process of elimination. And after that, the PI. So I have only two left. This is less than or equal 10 or greater than or equal 11. My PI is only 7. PI is equal 7. So in this case, this is out and this is in. So the answer so far, A24, as A24. So if the same problem is repeated again and I have answer A-24, so this is the answer, whatever answer B or answer C or answer D. This is based on the AASHTO classification system. Okay. Some of you added the 0 next to it. We have something called GI. It's called the group index. GI. GI, we use it only for the AASHTO system. And the GI is given by this equation. So GI, and I need you to know that the higher the GI, the less suitable soil. This could be, again, what is the GI? The group index. And if the soil is classified, by the way, A4 to A7, from A4 to A7, this is a silt and the clay. This is a fine. This is a fine. So the silty clay soil, where we have more than 35% basic number 200, that the GI is applicable here only. The GI is applicable to the soil from A4 to A7. I need you to remember that. And by the way, the A75 and the A76, if you are in the blue box, we use these two equations to decide which one we are in. Are we under A75 or A76 based on checking these two equations? So I need you to be aware of that. So A75 and A76. So we need to decide which one based on the okay. So here we are here. We are A24. So in this case, the GI, there is no need to calculate at all because you are going to get a GI. Okay, if the GI is less than 0, by the way, for the fine group or the fine, so in this case, the GI is 0. GI cannot be negative. This number one. Number two, the higher the GI, the less. For example, A6, for example, which is in this group here, A6, okay, with a GI of 15 is less suitable than A6 of GI 10. So the GI 10 and GI of 15, this is less suitable compared to the one with the GI 10. So the lower the number, the better, or the higher the number is less suitable as. So if I have the choice between A-6 and one it has 10 and A-6 15, he can ask you this question. By the way, he can give you an A-6 of 8 and A-6, okay, of, for example, of 12, okay. So I give you 10, 15, 8, and 12. And they ask you, okay, you are asked to select one of these soils, okay. Which one you are going to select? The A6, 10, A6, between parentheses 15, 8, or 12. So the higher the number, the less suitable soil. The lower number, the better the soil. So the lower number here is 8. I will pick this as the soil that is more suitable than the other types of soils, okay, as a good foundation material. Okay, good. So far so good. Great, great. So we need to be aware of the GI issue, just in case if he gave it to you, the GI, and so the A-4 all the way to A-7. We said that A-7, those are the fine grained soil. And as you know, the A7 is a broken down A7 5 and the A7 6 and the A7 6. Okay, so if you are between the A4 and the A7, so the GI, the group index, could be calculated. GI group index using the equation, and don't forget that the GI cannot be negative. So the GI, it must be greater than or equal 0. It cannot be negative. Okay, if the calculation came negative, we use 0, and the higher the number, and so it's inversely proportional. Okay, so the quality of the soil, quality, L-I-T-Y, quality, is inversely proportional to the GI. Okay, the smaller the GI, the smaller the GI, okay, the smaller the better quality. The higher the GI, the higher the GI, the smaller the GI, okay, smaller GI, the better quality, okay, and the higher the GI, the lower quality. So they are, so higher GI, lower quality, lower GI, better quality, okay, or more suitable. So the soil with the lower GI is better, okay. So something like that, just any way to remind you with the relationship between the GI and the suitability of the soil or the quality of the soil. Okay, going back to the original question, okay, which is this chart here. Again, the Unified Soil Classification System, USCS, Unified Soil Classification System. So the USCS, again, this chart, I would be glad to scan it and send these two sheets to you with my notes. Okay, try to help you as much as I can, and if you have it, that's good. If not, you will receive it. So the Unified Soil Classification System is a little bit more involved, or more, I don't like to say difficult. And this is the table for the Unified Soil Classification System. What we are looking for this, the group symbol, one of these. This is what we are looking for. Okay, and the table is divided into three main, in fact, two of them are the main one, and the rest, or the third one, is nothing, like the A8. So this is one, and this is two, and the third one at the bottom, the yellow one, which is organic material. Then nobody will ask you to do that, because basically it's very easy. There is nothing really need to be calculated or to be determined. It's just a matter of the soil has a lot of organic materials, either natural materials, okay. So this is primary organic matter, dark in color, and organic odor. And this is a highly organic soil. Obviously, this soil is not suitable at all. This is the worst. This is like A8, like the AASHTO classification system A8, or A8, this AASHTO group. A8 is the worst one. So basically, I am between the blue and the green. The blue one, this is a coarse grain soil, which starting with G or S, sand or gravel. The second one, which is the green one here, this is a fine grain soil. So again, by the process of elimination, we need to, first of all, we need to determine if we are in the blue box or the green box. The yellow, forget it, as I told you. And after that, we will proceed from left to right by the process of elimination until you come to one of these symbols here, a group symbol here, and the group name is here, by the way. The group name is here. For example, GW is well graded gravel, GP poorly graded gravel, and so on. So they give us the name. If you'd like to get more info, and also there is a lot of footnotes here at the bottom here. They are given the explanation for all these things. I need you also to be aware there is something called the plasticity chart. This is called the plasticity chart for fine grained soil. Plasticity chart. And we use it only for the fine, for the silt and the clay and mixture of silt and the clay. We have liquid limit and plastic limit because coarse grained soil like sand and gravel, they don't have something called liquid limit or a plastic limit, okay? Because they are coarse grained. And there is a handout, I don't know, I believe I send it. I would be glad to send it to you. I have more info about liquid limit and the plastic limit. Probably during the break, I will try to locate it. And if I locate it, I will be glad to go over it. So there are some questions you might be asked to determine the, but will be a dual symbols. Here it is, like this. This is dual, D-U-A-L. And this is, again, another, this for gravel and this for sand, dual symbol. So the moment that you see that it is SW-SM, for example, let me get closer here. Here it is SWSM, SWSC, SBSM, SBSC, or here GWGM, GWGC, GPGM, and GPGC. Okay, so these dual symbols, okay, could exist in one of the problems. Okay, and they tell us how can we determine this? Again, it's still the same. Okay, chart, and we can. Here we are lucky because the problem that he asked, problem number 525 of the NCEES, is just only a single symbol. So this is very easy one. So if you do have that chart, that's good. If it's not, here it is. And let me give you another 3 minutes, and we'll see what will be the answer. Which one of these? The same problem, 525. Okay, so let us see what answers I give a chance for all of you. So these easy problems, we need to guarantee them during the exam, because as I told you, there are some problems, they are really, really time consuming. I know if you have time, you will solve it for sure, but we need to guarantee the easy problems, the straightforward problems, because there is no any, if you understand the process very well and you know how to do the soil classification. So it's just a matter of applying the principle, and after that, you will get it without any difficulty. But there are some tricky problems and time consuming problems, and it may take more than 6 minutes. So in this case, we need to guarantee the problem that will be easy and straightforward. So I got, okay, I get, okay, I got two different answers. Okay, let us see. I got answer C and answer D. I got this and I got this. One of you or two of you, I believe. Okay, so we got SM and SC. Okay, so C or D. Okay, and we got another answer C. Okay, so if we look to this, we need to determine if I am in the blue or the green, which is either in the coarse or the fine. This is coarse. Obviously, as you can see from here, starting with S. S for sand. S for sand. As you know, the unified soil classification system, they are using letters like not like ash to ash. They are using A 1 to A-8, as we discussed for the ash 2. So it's called the A system. This is the best soil, and this is the worst soil. And the soil is deteriorating as we move from A1 all the way to A8. A8, nobody will ask you to use it at all, or nobody will ask you to determine it or to identify A8, because very easy and nobody is. Okay. For the Unified Soil Classification System, the USCS, they are using the 4 letters: S for sand, G for gravel, gravel is a coarse aggregate, by the way. This we call it coarse aggregate when we talk about concrete. Sand is a fine aggregate. And we still have silt and clay. So clay, they are using C. Clay. When they come to silt, I said, oh, S has been used one before. Here it is for sand. So they are using the letter M for silt. Okay. So those are the 4 letters, and the organic, they are using O, and O for organic, and they are using B for poorly graded, and W is well graded. And as you recall my discussion before, maybe I mentioned that, and forgive me, sometimes I repeat myself, sometimes I assume that I discussed something before, sometimes I don't. So the poorly graded soil, this is, they have the same size. Same size. Okay, well graded is diversified sizes. So the poorly graded, which is the same size, like all the grains almost the same size. Okay, this is what is meant by poorly graded. Well graded is diversification, mean that is a big one and there is a small one and there is, so diversification. Okay, so they are, the small particles will fit into the void of the big ones. You see, the analogy to that, and this is what I'm telling you, that sometimes I repeat my jokes, that diversified, like when you buy mutual funds. Mutual funds consist of different stocks. You are diversifying your portfolio, as the professional people, they use it. Okay, but same size, like one stock. I buy one stock. If the stock went up, I made some money, but if went down, I will lose all my money. But diversified, like mutual funds, they mixed of different stocks, so they are balancing each other. Okay, one will go up, one will go down. If you like to remember that way, I have no problem with that. It's just okay. So well graded, and I have a picture, I believe, in my books. You can probably saw it. This is what is meant by well graded and poorly graded. Okay, so the USCS, they are using the letters, the 4 letters in front of you. So we have the S, that means that sand, okay, not silt. Silt, they are using M, okay. So we are here. So we are in the top, because of course, okay, why we are here? Because more than 50% retained on number 200. If you remember number 200, based on the given problem, that I have 18% passed and the 82% retained. You see, so sometimes when you draw something like that, this is very good. So more than 50% retained, so I have 82%, so I am here. After that, I need to decide I am here or here, either a gravel or sand. You're moving from left to right. So here for the gravel, more than 50% course retained. Be careful, sometimes they retain, sometimes they, okay, passes. For example, here 50% or more, passes number 4. Here they are using retained. So I need to look to number 4. Number 4, I have 23% retained and 77% passed. So I have more than 50. I have 77. So I am here. So right now I need to move. If I am here or here. Okay. In this case, he said that the clean sands less than 5% fines. What do you mean by fines? Let's go to H. What is H? Okay. H, when we have a dual symbol for the sand. I don't have anything right now to indicate that. Okay. And after that, sand with fine more than 12%. So the fine, when they are talking about the fine, they are talking about the percentage passing number 200. So anything passing number 200, we call it fine. Okay. Or the fines. So the fines. So I needed to remember that. So I have 18% past number 200. So I have 18%. So sands with fines more than 12% fine, I have 18. So that means that I am here. So I am either SM or SC, which is the 2 answers, by the way. Here it is, SM and SC. The answers C and D, always they do this. They give us problems such that you are confused about 2 answers. Or so how I'm going to decide right now? I have fines classifying as ML or MH. Here the fines are classified as a CL or CH. This is the plasticity chart. So I need to come to the plasticity chart. Do I have the liquid limit for this job? Yes. Liquid limit is given to be 32. And the PI, plasticity index, is 7. So I have 32 and 7. So I have, this is 30, 32 is somewhere here. And 7 is here. So I am here. So I have the fines classified either ML or OL. ML or OL. Let us look to the chart here. So ML or OL. I have ML here. So my soil is SM because the fine is, or the fines is classified to be ML. So the plasticity chart will help me to decide between these two answers, and this is why the answer is C, which is the SM. So this is the correct answer. Agree or disagree? Those who selected D, I need you to be aware of that. Okay, you have to be going one more step in order to get the. Okay, so the soil classification, and I have some problems are really difficult. It's not an easy like this. Okay, but this is an easy one, and we need to make sure that we really understand what is meant by this and this and this. Okay, the this thing also that is related to, for example, if you compare this, let's compare this problem here, problem number 525, and we said that we have 525A, which is AASHTO, and we agreed on the 84, if you remember the 84. So you can repeat the same problem. And so if you compare this with this one here, let me give you a couple minutes to read it. And remember, you have only 6 minutes per question. So 6 minutes per question. Read it and let me know what do you think. Let us take about a couple minutes or so. Okay, obviously from my perspective or my opinion, if I read this problem compared to the problem we just finished, and this is the reason I'm referring to this problem, obviously this is an easy, straightforward, and it take probably, if we know the process and we're familiar with it, it's straightforward. There is nothing really very difficult or tricky around it. But these type of problems, which it has a lot of, if this happen, what will happen? If this happen, well, what will happen? If many scenarios, okay, the problem that they have more than one scenario or many scenarios. In this case, if the moment I look to the problem, probably I will spend very quick, half a minute to read it, and I know how to do it, but it will take more than 6 minutes, or maybe exactly 6 minutes. I will, if it's exactly 6 minutes, I will do it. If it is more than 6 minutes, I will skip it. I will say, okay, mark or flag, as they call it, the CBT, they flag it. The CBT, the computer-based test, which, by the way, this exam, the national exam is going to be the CBT very soon, and very soon mean 2023. This is according to the NCAAS. So the paper and pencil will be taken out, and you are going to be, or this exam, like the FE, like seismic and surveying in California and so on. So the trend nowadays is to computerize everything. Okay, so they would like to save time, and I don't know how they're going to handle it. And they already have some exams, by the way, the small group, but the civil is the largest. So they made it, to the best of my knowledge, to be the last group to switch from the paper and pencil to computer-based test. So if you read this, I say, oh my God, yeah, I know you can do it, but it will take time, and there is a chance for mistake or mistakes. So in this case, probably I will flag it and come back after. Maybe there is another two problem. Oh my God, welding. If I know the welding symbol, it takes only less than a minute. Okay, and so on. So we can, this one here, for example, 20 seconds or a half a second, 20 seconds, 50 seconds, sorry, or 30 seconds or a minute. So there are some problems are easy, and some problems are really time consuming. I will explain this. I will go over this tomorrow because I'm not feeling well today for some reason, the allergy. Shoring and reshoring. This one here. You see, the moment that you read the problem, this is a problem. To read it, maybe you will forget what's mentioned at the beginning, or you forgot exactly what mentioned at the beginning. And this is the given information here, and they give you a table to help you to calculate the load transfer. Something shoring is called shoring and reshoring. This is the reshores, and this is the shoring. When they build multi-story concrete structures, because the forms are expensive, we are not going to keep the forms here. The dark here, this dark here, these are the forms. The dark here, this one here, these are the forms, and this is form. Okay, and this probably still a fresh concrete. This is a fresh concrete. This is the last one. This is the one before. Okay, and as you can see, these are solid and these are dotted. This is reshores. Reshores mean that we provide support snug against this, because the forms, after they finish, they move the forms to build more stories, and because the concrete is not strong enough to carry the dead and the life load, so we provide what is known as called reshoring. This is reshore, and this is reshore. The vertical pipes to hold this in place. This is hardened concrete. This is hardened concrete. And this is hardened concrete. This is hardened concrete. Okay, no forms. Okay, here, okay, they could have two story like this for forms, or normally we use one story because to save time. Okay, to save cost, sorry, to save cost of the form, because the forms are very expensive. Okay, but here he showed, okay, as two stories that, let me use different colors here, and we'll talk about this tomorrow. And they came up with different scenarios, and they are relying on this. The book that they are using is SB4. SB4, the 8th edition. I bring it tomorrow. I'll bring it this, the 8th edition. They are, it is in the other, or this is the 7th edition, but it's still the same, except that they are using color for this edition, the newer edition. But the calculation, this is chapter 5. Let's go to chapter 5 to see what it used to be. Yeah, chapter 5. Yes, yeah, here it is. Shoring and reshoring. Okay, chapter 5. Here it is. Loads and the pressure, chapter 5 is still the same, and here they are using a little bit different symbols. This is the 7th edition, and different scenarios, and I'll explain it to you. And these are the columns that they are supposed to be filled, like exactly like this one here. So this is no longer, by the way, the 7th edition is no longer in use. They are using right now the 8th edition. So this is what I know. It's a very expensive book, about $280 or something like that. You are very welcome to purchase it. Okay, it does have two references. It has at the end ACI 437, I believe. So if you read the problem here, number 4, the problem that you when you read the problem, or the problem reading the problem, the time. So, and after reading it, so we need to be selective, as I said, that in selecting the problems, and yeah, because you must have a strategy in order to pass this exam. Don't insist on one problem because you know how to do it, but it will take more than 6 minutes, or it may take 10 minutes or 15 because you got upset, you didn't get the answer, and you know how to do it. But okay, so let's go to this, so we can wrap it up, because the allergies start to bother me too much. I don't know what's happening to me. So anybody tried to get the answer? Anybody got any one of these answers? Do we understand the concept of the problem? So he's saying that a contractor has scheduled work according to the network shown below in this figure here. Task A is performed by the contractor's employee, and it will take 4,000 labor hour of effort. So A, it will take 4,000 labor hour, LH. But we don't know how many weeks, because here he gave us 4 weeks, and here is 5 weeks. The contractor has 10 laborers, 10 workers available to work the task 40 hours a week, 8 hours. So this, how many weeks is that? So in this case, 40 hours a week. So 10 times 40 So this is 400. This will give you 10 weeks. So task A, based on this, it needs 10 weeks. Agree with me? Task A. Okay, so task A will take 10 weeks start to finish. So I have here 4 and 5. So which one is the critical path right now? The critical path is A. The critical path is A because it's 10 weeks from here to here to here. This is, so the critical path, if they ask me what is the CP, the critical path, okay, is a start, A, finish. Because what is the definition of a critical path? The critical path is a path that connecting all activities that has the least float, and always the critical path is the longest. So if I come from here to here to here, it will take only 9 weeks. But I hear this will take 2 weeks. Sorry, 10 weeks. Not. So this is always the critical path is the longest. Okay, this is why they call it the critical. Is the longest, not the shortest. So 10 weeks. Okay, so we finished. Okay, tasks B and C both subcontracted. So subcontractor will do that, and they have 4 and 5 weeks respectively. Okay, allocated in their subcontract. Okay, the labor cost $10 per hour for a straight time and 15 for overtime. The contractor estimates that it is possible to work 50 hours a week without impacting productivity. General conditions cost $1,000 per day every day the contractor or the subcontractor are on site. The optimum saving of the overtime is. So we need to see if the 50 hour per week option is going to save some money or not. Over time, because instead of being $10 per hour for straight time, it is $15 for the overtime. And there is a fixed cost, by the way, $1,000 per day. So we need to know if we are going to save some money or not. Okay, so do you understand the problem? Again, the wording is very, very important, and the language they are using. If you miss one word or one keyword, by the way, it could be really causing some kind of numbers to be mixed up or something like that. So let us calculate the straight time, okay, cost and the overtime cost and see how much saving. Take the difference between them. The numbers are so easy as far as the math is so easy, or the easy part of any problem, by the way. It doesn't matter transportation or construction or structure. Math is the easy part, calculation and multiplying. The most difficult part is to understand what is really given and what is required. So number 2, So let us look to the problem. So this is problem number 524. 524 of the NCEES. So I will look to the straight, no overtime, straight time cost, which is $10 per hour, labor hour. So we have 4,000 labor hour. This is what he said for the activity A. So in this case, how much they charge? $10. $10 per labor hour. So this will give us 40,000 for the activity A. Okay. And activity A, we said that it will take 10 weeks. Which is a 4,000. If you remember, the 4,000 divided by 10 labors and 40 hours a week. So this is 4,000 divided by 400. So this is 10 weeks. And we do have, by the way, $1,000 per day, okay, on the site. So you can say that 10 weeks or 50 days, 10 weeks, and this is 50 days, times $1,000 per day. So this is going to be what? It's going to be 50,000. So I have 50,000 here, and I have 40,000 here. So the total cost for the straight time, total cost is equal 40,000 plus 50,000. So this will give you 90,000. Any question about the straight? This is the first set of calculations that we need to do. Straight at $10 an hour. We know how many people are working and how many hours they're working. And there is like a fixed cost. Fixed cost is $1,000 per day. Okay, this is like a fixed cost per day. I have 50 days, which is 10 weeks. We calculated 10 weeks. We know how to get 10 weeks. And we estimated this to be 90,000. Right now, we need to look to the other option, which is overtime. So he said that task B and C are both for heavily created. That's okay. The contractor estimates that it is possible to work 50 hours a week without impacting productivity. So general condition exists, contractor. The optimal saving on working overtime is? The question is, who's going to work overtime? Remember the original schedule that this is 10 weeks, and they have here 9 weeks. So this is the critical path. So if we work 50 hours a week, and we know activity A needs this, $50 hours a week, this will make what? Remember, this is a critical path. Right now, if I make this 50, this is 4,000 labor hour, okay? If I can make these weeks or this duration exactly at the same duration here, we are going to finish together. So if we make this duration to be 9 weeks, so in this case, I can keep these people working like this, and I can work overtime here to reduce this to make it 9 weeks to match these. And I'll see how much extra I'm going to pay to perform activity A. Are you following me? So if I have right now activity A, which was originally 10 weeks, now I will say that 4,000 labor hour I need to make it in 9 weeks only. To match the other two activities B and C. So we can finish at the same time without any delay. We are going to meet here. So if you do that, so how many hours do we need to work per week? Let us calculate that. So it is 4,000 divided by 9. This will give me 444.44 hours per week. Okay. Remember, I have 10 people are working here. 10 times 40 hours a week. So it is 400 hours a week. This is the standard pay. To finish task A in 44 hours, 0.44, that means there is a difference. How much? Delta. How much delta? The delta is between 400 minus 444.44 hours. So this will give me 444.44 hours. Do you agree with me? So right now, let's calculate the cost. Since I know how many hours it will be straight hours and how many hours will be paid the $15 an hour. Okay, so right now, the cost for with overtime. So I have straight, I have 40 hours a week. Times I have 9 weeks, and I have 10 workers working over there. So this will give me the straight, okay, 10, sorry, I have 9 weeks, $10 per week, $10 per hour, sorry, $10 per hour. And we can say 40 hours a week and 9 weeks. Here it is, $10 per hour, not 10 work per hour. This is the straight. So this will give me what? Will give me 40, 9 times, 10 times, I get 3,600. 40 hours a week and $10, 9 weeks, but I have 10 workers. I have 10 workers, so I multiplied by this for 10, another 10 workers. Forgot that. So it is 40 enter, 9 times, 10 times, 10 times. So this will give me $36,000. This is for the straight, which is $10 per hour. Okay. Let's go to page number 3. I need right now the overtime, the OT. Do you remember how many overtime we have? We need 44 hours. So I have, okay, 44 hours, 44.44 times the, this is the difference in 9 weeks. So I don't have to multiply it by the weeks. So I need to multiply it by 10 workers times $15 an hour per labor hour. Okay. So in this case, we do have the, this is for 10 workers, so we need only 9 weeks here. 9 weeks. So it is 44.44 enter, 9 times, 15 times. I got $5,999.40. This is 9, by the way. 9. This is 9 weeks. Because 44 per week. Okay, so in this case, I have this additional. So I have the previous one, I have 36. So 36,000. So the total cost will be 36,000 plus the 5,999.40 plus, don't forget the last cost, which is, it is $1,000 per day. So I have $1,000 per day times 9 weeks times 5 days a week, because the number of weeks right now reduced to 9. So in this case, we need to get the total cost. This number here will come what? 1,000, 9 times, 5 times, it is 45,000, and 599.40 enter plus, and 36,000 plus, I got 86,994.999, sorry, 0.40 versus what? Versus the 90,000 that we calculated before. 90,000. So 90,000. So the difference, or the saving, if you like to call it, is equal $90,000 minus 86,999.40 will give us in the neighborhood of almost 3,000. 90,000 enter 86 999.40 minus is about 3,006 or 0.6. And this is why I will select the answer to be A as an apple. Do you see the calculations we did so far? Assuming that we didn't do any mistake. But do you understand the problem? What is the concept of the problem? The concept is very, very important. That the original, we have activity A and the activity B and the activity C. B and C, and this is A. And this is the start here, and this is finish. Okay? He told you that this will take 5 weeks and the other one will take 4 weeks. That means that these two activities, I cannot start. This is 4 weeks, and this is 5 weeks. And the activity C cannot start until activity B is done. And I cannot reach the finish until I spend 9 weeks. So this route here will take 9 weeks. Originally, based on the work required here, I need 10 weeks. He said I can work overtime. And instead of finishing this and wait, we can finish both of them at the same time. But the rate, $10 per hour, the standard time or straight time, and $15 per hour for OT, for overtime. If we decided to go with the overtime. So he said that, are we going to save money? And how much is the saving? So in this case, this is 9 weeks and this is 10 weeks. I made this to be matching this. And they start to calculate the cost of this based on 9-week duration. So the people will work extra hours or more than 40 hours a week. So anything beyond the 40 hours a week, as you know, is going to be overtime. Per week is going to be OT. But the overall, we're going to save. And instead of spending 10 weeks here, we make it 9 weeks. Do you agree or disagree? And always, by the way, as I always mention, and here I'm going to scan it and send it to you, but you can look at it and see. Always ask yourself, as far as calculations, ask yourself, do we have or do I have another method or another approach, or way or technique, whatever you call it, to solve the problem? For example, I just solve it, or we work it together. You may disagree. Will tell me that, Dr. Mansour, there is a shortcut. So always, is there a shortcut? A shortcut. Very important. If we can, by looking to the problem, and I said, oh, why I'm doing all this? I know there is 1 week difference between these two. I will take the 1 week, and this will be the saving, and that's it. One week. And work it differently, since you know the difference is 1 week between 9 and 10, but be careful with the overtime. Are you following me? So I hope that that this is is helping you guys. Okay, so I will be here tomorrow at 9 o'clock again, so I have to stop here. I will make a copy of the 3 sheets I covered so far with you. I will make a copy of this, and then make a copy of this, of the AASHTO, and at least you can look them tonight, and after that we will continue our discussion tomorrow. Okay, and we'll see. If you have any question, you can email it to me tonight. Sorry, I have to leave right now. It's just the allergy is a little bit bothering me, so let's meet tomorrow at 9 o'clock, and we'll continue. I hope I can spend a very good time tomorrow with you guys to talk about shoring and reshoring, because it is a little bit tough, plus any other question that you have in mind, and I'll be glad to do that. Okay, good night, everybody. Thank you very much again for coming today.